Hey, do we have an Anthony Riley?
Yeah, we do. Yeah, can you hear me?
Howdy. I'm doing all right. How are you? I have to say, I'm a little honored you're here.
There's no need for. I appreciate the politeness, but there's no need. I know that most people in your side of the topic think that I'm a complete and utter Ed-the-ball. I saw your message to Rachie. Just trying to work out why my camera's so zoomed in. Is it?
I don't know. Is that? It's weird. That might be. Haha. Is that better?
Yeah, I think so. Yeah. Let me just bring this down a little bit. I realise that half the people on your side think that I'm a complete Ed-the-ball or dishonest or whatever. And I saw you comment on Rachie's video, and he said that, and I want to quote it because I think it's beneficial if we discuss the way that you said it on Rachie's video, because I think it's important. Your words were, here we go. You said, why are you twisting what we say? Personally, I've been very clear that for the situations that you are speaking on, density is relevant. Well, density is not. In Rachel's video, density is not relevant, and she describes our weight is mass times acceleration due to gravity. And in there's no reference to density. There's no reference to volume. So you're saying that it's relevant, but the current position in science doesn't acknowledge volume in any way, shape, or form. So I agree with you on that, but that's not the position in your science that describes gravity. And then you say,
I've got someone else who wants to come in, but please keep going.
Yeah, and then you say anyone that says otherwise is lying or trying to sell you something, perhaps. The key point is what causes the motion. And that's really the million-dollar question, isn't it? Because Newton thought that it was insane that there would be an innate force between the matters or the masses that attracted each other, because he thought that was crazy. And Einstein said that there wasn't a force there. There was the effect of the curvature of space-time causing an apparent acceleration. But in the real world, we can cause the acceleration that both Newton and Einstein appear to have got wrong. And I agree with you. We should try and establish what is the cause of the motion. But that's what we have scientific method for. If we adhere to scientific method, we can establish the cause of the effect by manipulating it directly. And that's what I did.
All right. Well, one sec. That's a lot to unpack, but we can talk about the scientific method in a moment, because I really have been wanting to pick your brain as to where it is you learned your variety of scientific method and why you refuse any other interpretation. But yes, Newton did not like the fact of what he referred to as action at a distance. He didn't like the idea that you can impact the motion of an object with no obvious physical thing. But he accepted the fact that his equations perfectly described the motions that he was seeing. He was able to perfectly describe the orbits of planets. He was able to describe Galileo's experiments. Einstein came along, and then Einstein came along and basically said, this fails because of certain situations, and actually it had nothing to do with Newton, it had to do with Maxwell. And he basically said that, yet again, or as you pointed out, it's curvature of space-time. But the most important thing I want to say before I turn it back over to you is neither of them refuted that there is an attractive thing between two masses.
That's not true, right? First off, Newton's equations didn't explain the orbits, as you incorrectly stated. They didn't account for the epicyclic nature of Venus and what we now call apparent retrograde motion. So they knew that Newton was wrong.
It did. Actually, no, I'm sorry. I'm going to need a citation on that one. What do you mean by the epicyclic nature of Venus? I thought you were
both Mercury and Venus demonstrate what we now call apparent retrograde motion, and Newton's equations didn't account for the epicyclic.
Can you describe for me what that retrograde motion is?
It's the appearance.
I think I know what you're talking about, but I want to be clear.
It's the appearance that the target appears to be moving backwards from our perspective.
No. So that actually can be explained by the heliocentric model.
Perhaps, but that wasn't my point. My point was that Newton's equations didn't account for that. They couldn't explain.
Actually, they did. You can derive Kepler's laws of motion from Newton's law of gravitation. You can Google it. It's simply done. And those apply to every single planet. If
Kepler's third law of interplanetary motion Kepler's third law in interplanetary motion gives you a relative scale in which all of these celestial events occur, but they don't give you any actual sizes or distances, and that's the problem with them. You need to be able to get the sizes and the distances to be able to map it out the solar system the way the heliocentric model claims that it has done.
The Kepler's laws, you're right. Kepler's laws are proportionality. Basically, if written correctly, Kepler's law are the period of the planet divided by the period of the Earth squared equals the size of the planet's orbit divided by the size of the Earth's orbit cubed. So you're right. All Kepler's laws can tell you in and upon themselves are the relative sizes. But we have used the eclipse of Venus or the transit of Venus to determine the absolute distance to the sun from the Earth, which gives you one of those unknowns, and we know what the period of the Earth's orbit is because we can measure the day or the year. That gives you the other one, which then turns everything into absolutes.
There's two assumptions made when they use the transit of Venus to calculate the distance to the sun. You can't make any assumptions when you're calculating distance. You either need to know its actual size or you need to know the actual distance, and neither are known. But if you make two assumptions, then you can plot out how far away and how big Venus is, and you get the rest of the solar system done too. Do you know what the two assumptions were that were made by Christine Huygens when he calculated the distance to Venus?
I'm actually not familiar with that, no.
He assumed that Earth was a sphere, applying Eratosthenes' calculation for the circumference of the Earth.
Okay.
And he assumed that Venus was the same size as Earth. And he had absolutely diddly squat evidence to support that assertion. I could just as easily say that Venus is the size of Jupiter, or it's bigger than the sun, but it's trillions of miles away. But the point is, he doesn't know how big or small these things are. He doesn't even know that the physicalities. All he knows is that there are light in the sky.
That is the second point. You're actually spot on with that. This first point, I would argue, and that's a separate argument entirely, that the assumption of the Earth being a sphere is a very good assumption. The assumption that Venus is the same size as the Earth, yeah, he went out on a limb on that one. He said, based on the assumption of Venus being the same size as the Earth, or relatively the same size, then this is the distance that I would get. And as it turns out, he's right. The size of Venus is roughly the size of the Earth. And we have demonstrably shown this through satellite tracking.
No. Right. So first off, if he doesn't make the assumption that Venus has got a size to it that's comparable to Earth, or he doesn't make the assumption that Eratosthenes calculated that Earth's circumference was a given value, then he has got no idea what size the Venus light in the sky is. You can only see a light. So you can look at that light, and I can look at that light, and I can say, I wonder how close or far that is. And neither of us have got any idea whatsoever. But if you make some assumptions, then all of a sudden you can then apply Kepler's third law in interplanetary motion, and you've got the whole solar system. But if I say to you, don't make the assumptions, then you haven't got the solar system anymore. So are you saying that because you can make assumptions, and then you can then do further research based on those assumptions to validate your position when you made the assumptions, that your assumptions are legitimate in the first place? Because I don't agree with you, they're not.
Yes, I if I'm understanding you correctly, and I'm afraid this is going to bite me in the ass, but if I'm understanding what you're saying correctly, then yes. So what ultimately happens is that in science, you frequently have to make certain assumptions. You then bear out the experiment or observations based on that assumption, and then you come up with the result. And then you say that based on these assumptions, if you're honest, based on these assumptions, this is the results that I get. Then someone else will come by and basically come up with some people will reproduce your experiment to make sure that that is accurate. And then others will come up with an independent means via which to prove whether or not that assumption is viable or not. And with Venus, that has been shown.
I can agree with that, because your preface started off by saying that if you accept that the distances are whatever based on those assumptions, well, based on those assumptions, I would agree that is how they appear. But what if he'd have assumed that Venus was as big as, say, Jupiter, or as small as the Moon? That would put Venus much closer or much further away. And then if you then plot out the solar system based on those assumptions that the different sizes, because he's assumed that they're bigger than or smaller than the Earth, Jupiter, or Venus, then the solar system goes proportionate to those differences that you've assumed. So, yes, you're right to say that if you assume those values, then based on those assumptions, the solar system is accordingly. But You don't know that. You're putting values, you're adding quanta to a scale, but you haven't got the quanta values, you're just guessing them.
We're not just guessing. Huygens guessed, and then when we started sending radar signals to Venus and actually timing that signals and getting a distance, then we knew, well, that was one little proof of, or one strong piece of evidence that the assumption that Venus's size is roughly the same size as the Earth was correct. It is a good assumption.
You think the ping reflections to and from Venus were strong evidence that the Venus is as far away as what you claim?
Yes, I do.
Okay, let me. I want to screen share so that we can go through the actual evidence that is for the Venus ping radars, and you tell me how strong you think it is based on what's written here. This is from NASA's webpage. I'll put a link. I don't know where to put the link, but nasa.gov, history.nasa.gov, and what we're looking for, if I go to the top, it's called Fickle Venus, and it's to do with Jodrell Bank. Jodrell Bank happens to be about 15 miles away from my hometown, and I can get to it pretty easy. It's owned by the University of Manchester, sure. Which is my previous university. So it's kind of a home to me. I've got a little bit of sentimentality to it, so I'm familiar with it. And in this document, there's a guy called Bob Price, and you need to understand the relationship in the document. And I'll encourage you all to read it because it is worth checking. But Bob Price is essentially the mentor in NASA who's providing the funding to build the telescope in England. So JPL and NASA. JPL is the governing body that's monitoring Jodrell Bank, but essentially JPL is funded by NASA. So essentially NASA's money goes to JPL. JPL's money was going to Jodrell Bank. JPL are basically preparing to go to the moon. They're preparing for the Apollo moon missions, right, at this time. And in this document, we can see that Bob Price is overviewing what's going on. And what they're doing is, as you rightly say, they're trying to ping data to and from Venus, and they're trying to get the time it takes for Venus for the ping to come back. Now, the problem is, if you make the assumption that Venus is a particular size, then you're going to look at the length of time for the ping reflections to be bounced back to Earth. And if you ignore the fact that the Earth's physically moved its position whilst you've pinged it across and then come back again, it's no longer in the same position. But if you believe that it's a certain distance away, that because you're looking in a certain time frame for your ping reflections, if you've got that distance wrong, you're going to get false positives because you're going to see stuff that you think might be there to reflect the ping reflection, and it might not be at all because you might be looking in a totally wrong time window. And what I'm going to show you here is what Bob Price says. Now, the guy that was in Jodrell Bank that was writing this document wanted to do a PhD, and he needed this to work for him to be able to write about it for his PhD. So he has a motive, first off, right? But listen to what it says. Sure. It says Kingston's maser was installed at Millstone Hill just in time for the inferior conjunction of Venus. However, a klystron failure left only 265 kilowatts of transmitter power available for the experiment. On the 10th and the 12th of February, 58, the radar was pointed to detect Venus, then some 45 million kilometers away. The radar signals took about 5 minutes to travel the round trip in distance. Now, bear in mind that radio waves are light, they're part of the light frequency, and they are subject to refraction. We always get told about the refraction argument by your guys, but there's no consideration of refraction in this argument. But anyway, bear that in mind.
I don't understand where would refraction come into play here?
When the radio wave leaves the Earth's atmosphere, it'll bend down a little bit, and then when it comes back in, it'll bend down a little bit as well.
Well, why are you making an assumption that they didn't take into account refraction in their observations? It makes no mention of refraction either way.
Well, saying you don't know
that it didn't take into account refraction is making an assumption.
You don't know whether they did or didn't, but in the document you are right to say that it doesn't reference it, so we can accept that there was no reference to refraction made. But the point is that if refraction is not taken into account for, given that it changes like how the behavior of light is, that's going to affect where the light is supposed to be bouncing back to upon reflection.
Sure, but the other two things that were because you don't know whether or not they did not take into account refraction. They very well could have. And two, you also have to look at the beam size.
It didn't say it, so we can assume based on the silence that they didn't account for it. But let's just say they did.
No, you can't. You cannot assume something that isn't in evidence.
So, Sleeping Warrior.
Hang on. So, if I assume that they did or didn't take into account refraction, you take issue with that. But when Cassini or Christine Huygens, when they make assumptions, you don't have any problem with that. Why is it a double standard when I do it?
I make a problem with if someone clearly states an assumption, I'll take that at face value. When there is an absence of evidence, I'm not going to assume that they didn't take into account something if it's omitted. Did they take into account wind factor? I don't know.
So something that I want to ask.
They do say that they make an assumption.
Sleepy, let me ask you a question. Is this an article you're reading, or is this a scientific paper that's peer reviewed? Because if it's an article, they're not going to bring in everything that they've done. If it's a scientific paper, they will tell you everything that they've done so that it can be properly peer reviewed.
This is a document from NASA describing how
This is a history. And actually, Anthony, if you could read the last sentence of that first paragraph for me, please.
All uncertainty was swept aside when JPL obtained the first unambiguous detection of echoes from Venus in 1961.
Yeah. So whatever you're talking about, they probably, you're right, they probably failed. They probably did something inaccurate, which this describes probably in very good detail. But that does not mean that in 1961, they actually got radar signals from Venus, which illustrated its distance.
So what you're about to say then is that no matter what I bring back to you, because it says that it was unambiguous in the first paragraph, you're going to accept that it was unambiguous, regardless of what I say.
In 1961, unless you have evidence beyond 1961, then, I mean, you're describing a failure, one failure to this.
No. This is where they got the ping reflections from Venus. So if you're going to say to me that I need to provide more recent than this, that would be your claim that you need to furnish, not mine.
Your citation, the one thing that you're saying is saying they got unambiguous detections in 1961.
Yeah, but do bear in mind that this is written by NASA, and they're not exactly unbiased, are they? And they are providing the funding for this.
Okay, so you're making the assumption that NASA is in fact lying.
No, I am rating the credibility of the evidence provided by somebody, NASA, that is clearly biased in favor of supporting their existence by claiming successful results.
So you're saying that in order to bear that down or to distill that, you're saying they're lying in order to keep themselves in business.
I'm saying that from a credibility perspective, they need to show successful results to justify their existence. Therefore, they have a bias. Therefore, you have to take them with caution because they are biased in favor of their own success.
So, who would you not say has a bias?
Well, when we're talking about woo-woo land, nobody, because if I do a test, you'll say that I'm biased against it. If you do a test, I'll say you're biased in favor of it. So there is no way to be naturally unbiased.
So how do we take anyone seriously then?
Well, this is why we look into what they actually did to see can we objectively accept or maybe say, you know what, maybe it wasn't as clear cut as what they claim it was, and obviously that you've been influenced by that last line in that first paragraph, and perhaps they didn't get it as clear as what they say.
So because they failed once, we shouldn't accept that they failed or they succeeded any other time? The statement says that they unambiguously succeeded in 1961.
This would be the conclusion of the point, because if you say that this is antiquated and it's no longer the current position, then I would say, okay, show me where it is. And the problem is, it's all based on the assumptions that Venus is. It all comes from Christine Huygens' assumption that Venus is the same size as Earth, or relatively the same size as Earth. It does. Because if you don't make those assumptions, when you're looking for the 6-minute time interval for where it says, because here it says, look, it says of the 5 runs, no, hang on. Where is it? It says something about 6. There you go, 5 minutes. So if you don't have those assumptions and you say that Venus is significantly closer and significantly smaller, that time it takes for the ping reflection might only be 5 seconds.
You know what I mean? They didn't see the 5 seconds. They saw a return in 5 minutes, exactly as it was predicted.
They never looked there. They used Christian Huygens and they used Cassini and they used Eratosthenes. And based on those 3 assumptions or those 3 claims that those 3 people made, they basically looked at around that 5-minute mark for the reflection.
No, they didn't. I can tell you how science is done. What they did was
when
they
you say
took
science,
a chart recorder like this. They stuck it on. This is a radio signal. This radio signal, I stuck it. I pointed it at the ecliptic plane or the galactic plane of the Milky Way, and I waited, and I waited, and I waited. I took a calibration signal, and I waited until I got to the actual plane of the galaxy and recorded an H1 measurement.
So you said that you can tell me how science is done. We need a definition for science, and we need to compare and contrast it with pseudoscience so that we make sure that we are actually doing science when you claim we're doing science. Okay. And one of the things that science requires, other than observation, is experiment. Pseudoscience says a collection of beliefs or practices mistakenly regarded as being based on scientific method. Now, the problem that we've got is when you say I can explain how science is done, if the word experiment doesn't come out your mouth, then you're not describing science. You're describing something else.
Or observation.
No, it's both. It's not one or the other. It's both.
Give me Google me up a definition of scientific method.
Definition of science: the intellectual and practical activity encompassing the systematic study of the structure and the behavior of the physical and natural world. This is the key bit. Through observation
and experiment.
Yeah. So it's not observation or experiment, is it? It's observation and experiment.
No one is saying it has to be one or the other. That's just saying observation
you did just 2 minutes ago. But the point is that if it's not got experiment and it's failing to adhere to scientific method because it's not got any experiment to apply scientific method to, then by definition it's pseudoscience. When you've got your graph there, is that science? Is it a measurement of something? Therefore, an observation. Right. Yeah, now, is there an experiment that goes with that complies with scientific method? Or is it just a recording of something and you're calling it science?
So let me, where is it said, please, and Google it if you want, where is it said that an experiment must have an independent and dependent variable?
It's the 3 constituent parts of an experiment.
Google me that. I want to see that in writing. I want to see that it must, not that it has, but must have an independent and dependent variable.
Right, the constituent parts of a scientific experiment. Let's get rid of that. Right, so 5 components of a well-designed scientific experiment. Are you ready?
Yeah.
Now, this is from Sciencing. I would say that this is not strong evidence. I would say that it's persuasive. Is that me or are you?
I think that's
Where's that noise coming from?
Not me.
Somewhere on here. Hang on. Oh, it's that. Sorry.
That's all right.
What was I saying then?
You consider this to be good, but not exclusive, sort of.
Yeah, because it's sciencing.com. Now, I don't know who writes sciencing.com. But when it's lacking an edu.citation with it, I'm always a little bit more dubious because this could be written by you, it could be written by Norman, or it could be written by a flat earther and tailored accordingly to based on whether you accept science to be experiment based or whether you accept it to be observation based only. So it depends on where it comes from. But this one says,
I agree. Like you need to be very critical about your sources. Yeah,
you've got to be careful. But based on what it says, let's see what it says. Observation and question. Observation. So we're all right with that. We've got the observation, right? Hypothesis. Hypothesis is a prediction of the outcome, which is generally stated in a complete sentence.
That's not what I wanted to do. Sorry. No, I'm sorry. Keep going.
So the hypothesis uses the observations made before the experiment to make an educated assertion. That's what I did with my egg test, wasn't it? We observed that some things appear to sink, some things appear to float, some things appear to be suspended within their medium. We see suspended particulate matter all the time, plankton and pieces of wood and whatever. But it uses the observations made before the experiment. So on this citation, and I'll concede this is only one, but it's clearly referencing you make the observation first, then you do the experiment. I am not
disputing that fact or that aspect of the scientific method.
But you asked me for a specific citation that said that experiment was included as well as observation, and that's one.
I said it must say an independent and dependent variable are the only way to define an experiment.
Okay. Well, they're the constituent parts of an experiment. So let's go back to that citation and see, because I forgot that you asked about IV and DV. So let's check what it says for the experiment bit. Method. So the experiment, the method section of scientific method lists all the materials used in this scientific method. Yeah, to be fair, that doesn't actually it doesn't talk about at all the experiment part. It just talks about the results of it. So we need to go to a better one that's like not aimed at school kids.
Yeah, that would be nice.
Canvas.hull.ac, components of a scientific report. Let's go to Lumen Learning. I'm not sure whether this would be any good. We can try that. Oh, this is in the context of psychology, so I'm not sure this is going to be enough scientific for us to be able to. Here we go. Let's zoom in a little bit. Okay, make an observation, ask a question, form a hypothesis that answers the question, make a prediction, do an experiment to test, analyze the results. All right, let's see whether or not it talks about IV, DV, and control.
Hold on 1 second. Go back up a little bit. It gives you an example of an experiment.
Yeah, because you want to see specifically where it says IV, DV, and control, though, right?
That's because that seems to be your point of view, is that if it doesn't have an IV and a DV, it's not a proper experiment.
Well, if it doesn't have an IV or a DV, what would you call it?
I would call it a planned observation.
I'd call it a correlation.
And then a modeling. So, and then
I'd call that reification and correlation.
And what is wrong with correlated data? If you can show that correlated data is correlated because of a physical causal effect between the two objects or between the two.
No. That's the opposite of a correlation. A correlation doesn't have a physical causative fact.
Yes, it can. It doesn't have to, but it can.
Well, it can, but it doesn't identify or prove it. It correlates the data with the observed result. So I'll give you an example.
When you look into the physical underpinnings of what's going on. For example, climate change. We know that that CO2 gas and we know that temperature are correlated. Those two things are ramping up at exponentially high growth, but we also rates. And we know that CO2 contributes to global warming. So
we also know that CO2 is plant food. So let's not go with something contentious. Let's go with something that's not contentious. Let's go with smoking. Let's go with smoking, because I think most people do accept that smoking causes cancer.
Not everyone, but yes. All right.
So Antonio Subirats was a smoker, and he got throat cancer and died.
Rest in peace.
Yeah, and he did die of cancer. Thankfully, so far, most people don't throw him under the COVID bus, but nonetheless, he did die of smoking-related illness caused by smoking, and it was cancer that killed him, and it was of the throat.
No. See, that's the problem, is if you want to be very specific, smoking didn't kill him, cancer killed him. And we can say that more than likely his smoking, or we can say that his smoking contributed to his risk of getting cancer, but no one can prove to you that smoking was what caused his cancer. It could have been genetic.
This is against your argument that observation can be the causative fact, because you said that if we do an observation and we correlate, then we can prove with a causative fact that something did cause something.
I'm sorry, if I said prove, I highly misspoke. We don't, as to quote MC Toon, we don't prove anything. We give evidence. And with climate change, we know that there is a physical that CO2 physically traps heat. And if we know that CO2 physically traps heat, and if you have more CO2 in the atmosphere, it makes sense that you would see the atmosphere get hotter.
Okay, so when you said then, MC Toon says that we don't prove things in science, essentially. But let me just stand corrected. You did not say the word prove. I said that in error. You didn't say prove. But what you did say was if we have correlative observation, then it shows that there is a causative agent. That was what you said.
Not necessarily. No, not necessarily. It can or it can't. One of the things
it can never show causative agent because you haven't manipulated the presumed cause.
See, that's where we're getting back to the IV-DV thing. Why is it you have to manipulate anything?
Because that's the definition of the independent variable. I put 10 citations for the IV in my video for the eye test. Have you not seen it?
But the thing is, give me a citation that says an IV is necessary for a proper experiment.
Well, if you don't have an IV in an experiment, so you want to citate, right, okay, I can. But if I've just gone to the first one, IV and DV. In research, variables are any characteristic that can take on different values such as height, age, species, exam score. In scientific research, we often want to study the effect of one variable on another. For example, you might want to test whether students who spend more time studying get better exam scores. The variables in play are called, there we go, the variables in a study of cause and effect relationships are called the IV and the DV. The IV is the cause, the DV is the effect. Well, if you're not going to have those two values in an experiment to demonstrate the cause of an effect, then what is it that you're actually going to be thinking that you're doing? If it's not going to be an IV-DV relationship, what is it going to be?
So in this case, CO2 levels are the independent variable that is being manipulated by human activity, and temperature increase is the dependent variable. And when I say this, what I'm talking about is we can look at past geologic history to find out pre-humanity. We can look at what the CO2 is doing for natural sources, volcanism, plant landmass or biomass regeneration and decay. We can look at that and we know what the CO2 should do, get with the how those two things should relate. Once we get into the human side of things, we see that with the Industrial Revolution, we burn through more fossil fuels. We add more CO2 to the atmosphere. Therefore, so we are manipulating the IV. We are getting a DV.